one to find the segments on that side, okay, on the particular side. So with this, EH6 over HG, which is the unknown, so HG equals FL 4 over LG 18. So cross product 6 times 18 equals 4 HG. Okay, so divide both sides with 4. So HG is equal to, so I can just, I would like I like to cancel out numbers, so like that one, I can divide this with 2. So the 4 divided by 2 is 2. 18 divided by 2 is 9. So the 18 becomes 9. The 4 here in the denominator becomes 2. And my numerator 6 can still be divided with 2. So no more denominator. I mean, it's only 1. And then because I divide by 2 with 2, because that number, that 2 can also divide 6. So 6 divided by 2 is 3. So now what I have in the numerator is 3 times 9, which is 27 over, no need to write over 1 because it's just 1 under 27. So HG is equal to 27. Okay, next, the opposite, the converse of mid-segment. Here you see HM is 15. So H to M is 15. H to N is 10. So remember, we're dealing with segments here, like what I just told you. We just deal with segments. We don't use, I mean, we cannot put in the whole thing from H to M or from H to K in our equation with respect to triangle proportionality theorem. So first is, we break down the 15. If this is HN is 10, then we're not given with NM, but we can use 15 and 10 to come up with NM. So NM is 5. So the ratio of this side, HN over NM, HN over NM, and on the other side is HJ over JK. Now to show that these two are parallel, we have to check if the ratio here is equal to the ratio here. If HN over NM is equal to HJ over JK. So HN over NM is 10 over 5 or 2. Now for the other side, we're not given with number, but we're given with description that HJ is twice the length of JK. So HJ is given with respect to JK, so we let JK as X. Therefore HJ is 2X. So HJ over JK is 2X over X, and so it's also 2. Since the two fractions, see, you can do them separately. You can simplify them separately, or you may do 10 over 5 equals 2X over X on cross product. It will still give you the same conclusion, that the two sides are, since the two sides are proportional, therefore NJ is parallel to MK. This is like investigating. Okay, you are still investigating if they are really parallel or not. Okay, so now let's go to one of the application of the mid-segment, and also for those that have wherein sides are congruent. You see this one here. Okay, so you see that it's the same thing if you have 3 or more sides, as long as they are parallel. So you have here parallel, so there is the fraction that you can get here equals to the fraction that you can get here. So if you're dealing with DE and EF, so DE over EF equals AB over BC. Okay, or AB over BC equals DE over EF, or say AC over DF equals to BC over EF, or AC over BC equals DF over EF. So you see that each fraction just came from one side equals to a fraction from the other side. So you just need to be consistent. Okay, so here, so you see only one side has a given indicator that they are congruent. So that means this over this is equal to 1 because this is equal to this. So if these lines here are parallel, then the same property applies to the other side. So that means even though they're not given to be congruent here, it follows already that they are congruent. It follows also that they are congruent because the other side are congruent. Okay, so the other side has a ratio of 1. Therefore, this side must also have a ratio of 1. And if the ratio is 1, that means the two segments are equal. You can only have a ratio of 1 if your numerator and denominator are the same. So you can now solve for x and y separately by just separating them with equal sign. I'll say AB equals BC and DE equals EF. So no need to make a fraction equals a fraction. And also it's kind of hard for you to make a fraction equals to a fraction because we're dealing here with two different variables. You cannot move forward if you say 3x minus 4 over 6 minus 2x equals 5 over 3y plus 1 over 3y. You will be stuck because when you cross product you would have xy and then xy on the other side. So use the other theorem. You use the indicators and just solve it in a simple manner. Okay, for check your progress here. These two are equal, so you can say 2x plus 1 equals 3x minus 5. Solve for x. And then the other one, 6y minus 2 equals 3y plus 5. Simple algebra. I don't need to solve that one. And then solve for y. Okay, so let's go over, check your understanding. I'll just give you possible equation and then you will solve later. Okay, so number 1, or with this figure, never mind the given here, just look at the figure. From that figure, the equation that you can use would be LT over LR equals WS over RW. It should not be an issue whether I write LT or TL, LR or RL. It's the same. WS or SW, they're the same. RW or WR, they're the same. So for these two problem, you'll be using this proportionality statement. So find a way to fill in this. Okay, so RL, RT. No, there's no RT. Like for example, number 1. In number 1, we have RL, which is 5, but we have RT, which is 9. So there's no RT over here. What can that RT help us? So that RT would help us find LT. If this whole thing is 9 and this is 5, therefore this is, yes, thank you for answering, it's 4. So that becomes 5 over 4 equals WS numerator 6 over RW. That is what we're looking for. Solve cross product. Number 2, again you're given with the whole length TR 8, but we don't need that one. It's not present in our equation here. So LR is 3. So if LR is 3 and the whole thing is 8, therefore LT is, yes, correct, 5. So LT is 5 over 3 equals WS is the one that you're solving for over RW, which is 6, and then cross product. Okay, the same idea for 3 and 4. So for 3 and 4, you will be using my over xm equals nz over xn. Okay, so in number 3, you are going to find for xy, but there's no xy here. So don't force xy to be part of your solution. Okay, how do you find xy? Xy is xm plus my. That means you need to find these two. Find these two so that you can find xy. So do we have xm? There is. Do you have my? We don't have. So that's the one that we need to solve first. So in number 3, we're going to do xm is 4, my is unknown, equals nz is 9, xn is 6. After you solve for my, to find xy, you will do xm plus the my that you have solved. So xy is equals to, I don't know, you can solve it already. Number 4, we're going there. For number 4, solve for t. Don't be bothered with t minus 2, t plus 1. Just go back to the basic of what this lesson about parallel lines tells us. Okay, so xn, where is xn? On the denominator. So xn is t minus 2. nz is on the numerator, so t plus 1. On the other side is what? xm is 2. So on the denominator, xy is 10. There's no xy. So we need to use that xy to find our my. So that's my 2, so it's 8. Then cross product. That would be equals. You're smart. Answer that one. Okay? Clear? Last 2. For 11 and 12, very easy because these two, because of this, you can say 20 minus 5x equals 2x plus 6. And then solve for y equals 3 over 5y plus 2. The same thing here. 1/3 x plus 2 equals 2/3 x minus 4. Solve for x. And then 5y equals 7 over 3y plus 8. Okay, so I hope this video helps you solve the classwork for 7-4, and I hope also that you would turn in your classwork.